Good morning or good afternoon, depending on where you are. Welcome to SIG Architecture's sub-project for conformance. I'm Hippie Hacker, your host today. Rian in South Africa will be taking notes for us. On our agenda today, we've got a few items around our tooling and our request from the CNCF to have basically a talk condensed down for KubeCon virtual, and we need to commit to that this week. And Stephen would love some feedback on proxy endpoints, and John wanted us to know next meeting that we'll have a discussion, as Brad and Srini can't be here. Although Brad, good to see you here.
Yeah, but I'm dropping off in like 5 minutes, unfortunately, for a doctor's appointment. So I just wanted to see what was going on.
Fair. We'll get through some of the fun bits quick for you. I'll go ahead and run into this. We have a humax.org that's heavily used within our flow, and that's on github.com humax. But I'll do a little demo and I might do that after at the end, just so whatever time we have, we'll do it. I'll start it so that the deployment can run while we're working together. And I'll just do that in a terminal. It's the way that we have been deploying, not iTerm. Yeah, iTerm is a little nicer than the one that comes with OS X. And we have our Humax repo that has our infra, and our Packet has been super generous in donating resources for the CNCF to work on projects like API Snoop. And we have a cluster config script, which I'll share here in a minute. Is it Great Cluster? We'll look at it. I think it's cluster setup. So we'll look at it real quick. This is the Emacs inside of Kubernetes, inside of the containers, it's how we do all of our things. And in this case, it's pretty straightforward. Use cluster-cuttle to connect to Packet and bring up a nice setup so that we can, inside of that, as we're setting up the cluster, configure audit logging, because we lost the dynamic audit logging prior to 1.19. 1.19, we deprecated that alpha feature that was super useful for us. And make this a little bit bigger. And also, can someone drop a link in the chat to this file from II? Once we go through and bring up the cluster, we deploy an API Snoop database called SnoopDB as part of our deployment, and then also deploy Emacs within that goes through our org files to help us identify tests. So this is that script we're about to run. So that's cluster setup. And it needs a kind cluster. So I'm going to do kind delete cluster just to make sure we're starting from nowhere. So this should work on any cluster in the world that runs Kubernetes as far as the initial bootstrap. And then we're going to be creating a cluster on Packet from scratch. That will allow us to do all of our testing. So this cluster that we're creating is from Kind. It's on 1.18.6, which is just the stable version that this version of Kind is releasing at the moment. I'm sure very shortly that'll be 1.19. I
can send directly.
Okay, that sounds good. I'll try to keep an eye on chat. What this will allow us to do, once you have a cluster, when you run this script, by the time it's finished, it will be directly inside the test writing environment with all of the latest CI runs with the audit logs there, so we can query for untested endpoints, as well as setting up an audit logger sync that goes to a database you can query to see if the application that you're testing or writing or the A/E test actually does cover those endpoints. So if I run cluster setup, it will go through and first on this empty cluster, deploy all the CRDs from the cluster API in order to communicate and provision infrastructure on Packet. I might do is go ahead and drop that link. Inside Humax, we have our infra folder, and we have our cluster API folder, and we have you need to get a secrets ENV that you update with your secrets for your packet project ID and API key. If you're interested in helping us with this stuff, I'm sure we can get you a key. The other variables are some stuff for the size of the control plane nodes and worker nodes. Because we're just writing tests, we only bring up a single node. So our worker machine count is 0. These files are read by our cluster setup, which to make sure people don't accidentally delete something else, we read, are you sure this is the context you want to do? We're doing initialization. We read through and ensure that we wait for the CAPI webhook system and packet system to be deployed. Sleep for just a moment to make sure that we can create using cluster cuddle to create a packet from our template, which I'll bring up in a moment. And then we go through and check for the machine that's available on packet to come up. So if we go check our deployment, it is currently waiting for the packet cluster API provider, the control plane controller manager to come up before it does these next steps. While we're waiting on that, I will launch a new window, and we'll go up a folder so that you can see our cluster packet template. And this is the cluster API definition for our API server. Note that we had to bring in some extra files, both in the arguments provided to the API server so that we could have an audit policy and a definition for an audit sync. But I did not see an easy way for cluster API to pass files along, so we did some here docking in our post kubeadmin commands and our pre-admin kube commands. So for the pre, we do some stuff around networking to make sure that our control plane endpoint comes up. It's not part of the machine itself. It's a dynamic IP that's moved around in packet. Then we go through a pretty much normal Kubernetes deployment, including Weave, and set up Nginx ingress, and ensure that a few things happen down to get metal LB running. And at the very end here, we go through and clone API Snoop and use our customize to deploy the webhook that is the audit sync for our audit logs to be retrieved and done in cluster. Then we go through and deploy Humax itself, which is this cluster, this repo that we're starting from, using a Helm chart to deploy our API Snoop focused version of Humax, including setting our time zone to to your part of the world and your get options, so you can commit and push from within this truly cloud native development environment. We make sure that we just call the user II because what II is usually people pairing. So there's two people, so each of you are an I, and you share an SSH. Or in this case, when we're done, we normally hand out kube configs, because if you send somebody in the Kubernetes community a kube config to a dedicated box and say, here, run these commands, they'll understand a lot about that cluster as you're pairing together. And that'll make a lot more sense here in a minute as I share that with everybody on the call. In order for us to get the policy and the audit sync down, we make a directory inside PKI, because that's already propagated to the node, the packet node, and that deploys, so it makes sure that all the way through to the API server container that our audit policy and audit sync are in place. We actually, last steps there are to make sure that Docker gets installed before we end up running, because kubeadmin is used to deploy. So there's a couple of things for the node type, not much of interest in the rest of this file. There, so let's see how our deploy is going. It is still waiting for condition ready on this. Interesting. Any questions so far? Can you make sure we've deleted all of the other notes, like all of your extra notes from yesterday? I don't want to hit any quota related thing.
Quick question. So the steps that you just went through, is that documented on the UMAC website?
Let me pull up the website for HUMAX. So right now, the folder that we're in, I'll start at the top. So if you go to humax.org, currently that website redirects to the HUMAX org on GitHub, and there's a HUMAX repository. At the top level, if you don't want to do all the stuff we're doing in cluster just for HUMAX itself, not the way II uses it to use stuff in cluster, you can just git clone it in your home dir or anywhere on your system and just export the Emacs load path here with this locally, this local thing. I'll drop that into the chat. Oh, that was not the right URL. Let me try that again.
I guess my follow-up question is, if I wanted to run this locally or to run the conformance stuff locally, do I have to go through all the steps you just enumerated?
We have been using kind in the past, and so under our Terraform packet, here we have the packages listed here that we've been using on Ubuntu, and downloading the run commands to get to the point where we install Helm. Where is our? It's no. He's asking about on his own box. Like so, well, I think what Vladimir, if I understand what you're asking, if you don't want to use Packet and you want to do this completely on your own box, how do you do it?
Yeah, how would I set this up locally, or is it even possible?
Yes, it is. I'm trying to figure out where we have that information. It's probably in the in API Snoop. Because part of this is the deployment of setup with kind, and we're trying to figure out where our kind docs are. Maybe under org, kind plus audit sync. So this is from 20 days ago, so it may be a little bit, and this is a little bit verbose, it's kind of an exploration, and it focuses on like exploring Dockers and desktops, things at the top. This is how you would build kind to make sure your kind config was built from source. Then you would need to have your kind config itself. So I'd say this is probably a good starting point. I'll drop this into the chat wherever it went. There you go. That is the documentation for what you would need in your audit policy, what you would need in your audit sync. Note that this endpoint, this audit sync YAML, it's just a kube config, but it needs to have a hook. And so it sends it to this events, and our, doing a bit of crazy zooming there. The kind config worker nodes don't need it deployed, so it's kind of sitting here. I'm somehow touching, my screen is zooming around and my hands are in the air.
Magic.
That is some foo there. Give me a moment to figure that one out. I think in the same folder, if we look, those files are probably, they're not, we call it org tangling. So those, if you'll just take those two files and put them out, and we can probably put this out for you. So you need a working kube kind config for it to deploy. And the kind config has to do a few things. For us, because we use the Docker socket to communicate, and we also want temp passed in, our worker nodes have some extra things passed in. The control plane nodes add that extra mounts for PKA audit so that we can get the audit files within there. And that is based on the host path having an audit folder with those two files in there. These are the extra port mappings so that we can reach into the web services, or in this case 5432, which is a Postgres. And we do some patching to make sure that our ingresses come up, because we used to have a web interface that we would run. And then if you have a public IP, we use IINZ, II co-op, and sharing IO, and usually people put their username in front of it. So you have either a star certificate or a SSL ingress that sets up per server, also so that the kubectl will just work. So you can give the kubectl to a friend, for example, and it would just reach into that cluster. The main thing is making sure that within the API server, when it starts up, that it has the extra arguments to reach within the API server container to the files that have been brought in defining the sneak-in policy. So when the API server comes up, when the cluster is up and API Snoop is up, that all of the audit logs will go all the way into that database. So to create it, you just bring up your kube cluster kind create config, kind create cluster, kind config. And you can just use in this case, we were trying to do it from source, but you could probably do it sans using the latest version just by running that command. So all you need locally is kind and this kind config YAML.
Okay, thank you.
See how our thing is. This is on its way up. I've kind of just left it alone for a bit until it comes up. Sometimes it takes 15 to 20 minutes. The cloud init goes through, and that comes from clusterctl to not only deploy Kubernetes, but deploy all of the other pieces that we need for not just the API Snoop audit sync and configuring the API server to sync to that, but additionally Humax running within the cluster so that we have already checked out the API Snoop test writing repository, which will probably take out of API Snoop the repo within CNCF and put it as a test writing repo underneath the API Snoop org. Or maybe we put it in a SIG conformance testing repo, because that's the actual content. Our files, our org files, when we write them for tests, the org files export to Markdown, and we copy and paste that Markdown to create a ticket. So the flow is consistent in how we create these fairly complex agreements on what work is left to do, how we accomplish that work, and get it reviewed and approved by the community before we write our PR. Because we had some trouble early on. We go through and write the PR, and we may even get it all the way through. Sometimes we didn't, but then it wouldn't be conformance. And so we're making sure we spend as little time as possible going through and defining the work and getting buy-off by creating that ticket before we try to push it through the community. We can probably take a look at that by just looking at the GitHub Kubernetes org project 9. And anything where you see write some tests with some endpoints, I'll just click on this stuff that's in the sorted backlog. You'll recognize this very shortly, where it says, where's the original issue? This one does not have a PR yet, so it's just a ticket. And we have some SQL code that we run in cluster, inside Emacs, inside the org file, that lists the endpoints that we're going to focus on. And then we look through and find the documentation for, in this case, daemon set. And we have a mock test that says, from the docs and from my understanding from the community, these are the 6 steps that we think are important for ensuring a conformant cluster. And then we have a small, sometimes small, section of Golang code. This code does not use Ginkgo. This code is at the simplest level to show the logic of what the test would do. And it's not saved to a file, it's just saved to the org file and the ticket. And when we run that code within our org file, it creates a standard output. We normally just try to match that to what our test writing outline was up top. And that ran within the cluster while the audit logger was running. So then we'd select distinct user agent to do, did our live test writing Golang code actually hit the API server and show up in the logs? That's just a quick test. Then we say, well, from the endpoints hit by the new test, were they originally hit by some other EDE? And we can see that this test hit this one, but it hit these other ones that were not hit. So this looks like this might get about 6 endpoints. And if we have this other function, or the other SQL function, we select from projected change in coverage, we can note that previously old coverage was 181 points, now it's 187, and we can identify those endpoints by that list up there. We lost, yeah.
They posted in the chat.
Oh, you posted in the chat, I missed it.
Yeah.
Sorry, having bad internet connection today. Okay, we'll reach out to Clayton later. So basically, Vlad, it's you and us today. So feel free to be super verbose in your thoughts and questions.
Not a problem.
So
actually, I do have a question.
Yeah.
The ticket you were just showing, was that generated by the tool, by the UMax tool?
Yep. And then we can actually go back and find the original. So this is the apps v1 daemon set, and this is a KK ticket, right? But if I go into github.com CNCF API Snoop, the folder that our project will bring up here shortly is in the tickets folder. And the tickets folder has tickets for Ks. And there will be a, what was the name? Daemon set. So I look for daemon in here. I guess missed a little bit of syntax. Is it not in here? Maybe it's missing. I'll pull up one.
Okay.
That's really recent. Can I look for 2 months ago, last month. No, that's not it. Let's look for one for 2 months ago. We've been focusing on a specific set here recently. So this is node proxy options test from 2 months ago. Here's the org file for node proxy options test. And it renders in GitHub okay, but not necessarily perfectly, like our test outline is missing some things. But if we look at the markdown, we can see that it's a little more, they render them slightly differently. And when we're inside our cluster editing this org file, we hit a sequence that generates the markdown file. We don't have the automation in place to automatically populate the ticket. So our robot is Rion the ticket master, so that we have a human who can update the text in the top block of the GitHub ticket. Thank you. So that anyone can work on any of our tickets and still update the text of the top, because Rion's the one responsible for updating the top of the ticket. At some point, maybe we do that with a bot. I think you're soft muted, Vlad.
Yeah, so the generation of the ticket is automated. Does the consumption of that ticket also is automated? So
yeah, it is.
Okay.
Well, consumption. So we have some Lisp code that we wrote. I think that was Zach. He's on the call. And there is a take that code block that we wrote and turn it into a test. Is this it? Here's, yeah. This takes the mock test and turns it into a Ginkgo test.
Okay.
And depending on the complexity of the code there and some specifics in Ginkgo, it will create the text that you can drop into a file to create the PR. It's not fully automated because we don't know, we can't guess. I mean, I guess we could add a few more things, but right now it just generates the text, the Golang code, that is Ginkgo based on the non-Ginkgo code.
And the end result of that, the test that is generated from this process, does that make it back to the I guess the Kubernetes or wherever that test may land?
So these are issues with PR soaking. So we'll click on one of those, maybe a little more interesting. Okay. So this particular, this one is through steps 5 of 7. It updates that number as you progress through. So we have the approval issue, the API Snoop PR. So this is where we had the initial PR with an API Snoop, which was just an org file, no PR. So the markdown and the org file. So this is the markdown and this is the org file. And that feeds into the KK issue. and we take that code down here inside of the code block, and we run Zach's function on it to create a PR, and the PR is right here. So this is the PR for the test. So for this test, we added schema and Go and needed some JSON-y bits. And the Ginkgo it is the code that is generated from our Lisp reading of Golang org file. And there's how it came in, and it has all the expecteds and whatnot. That's a little different from the way we do it outside of this framework.
Okay.
This one looks like it's flaking a bit, and Liggett did a nice presentation on flaking in the last SIG testing meeting that always requires reading for anybody.
It is. It was pretty good. So that code is legitimate, although it wasn't human generated, right? At all.
Usually what happens is it's automatically generated from Zach's code, and then we do minor edits. But for the most part, it runs. Stephen, you could probably best speak to it, and Caleb is around the corner. He's in earshot. It's not perfect, but pretty darn good.
Right. I mean, it's a good starting point. I'm trying to figure out or understand the process.
Yeah, and what I'm waiting for here is for this to come up. We missed those last couple of steps there. So I will, let me see which cluster I'm on. Kubectl get, actually I'll do this, I split in these? I'm just gonna create a new one just to make sure. So in my Humax infra cluster API folder, if I do kubectl get machines all, we can see that packet ID is the packet physical machine there. And I just wanted to make sure that if I communicate to that cluster, I'm going to run these 3 commands in the other window over here. So the first thing we're going to do is, and I'll do this one step at a time so we can kind of see it all. If you retrieve it, that's your kubectl, this command here, and that's how packet, the cluster API works. And so just before that, I'm going to go ahead and export, I guess the base64 decode it. Decode. So now that's our kube config. I'm going to put that in my kube folder and just make sure that it's my packet HH Humax. And how can I easily do this? Vlad, since you're the only person on the call, I'm going to send this file to you via Slack, right?
Okay.
So let me find you in the Slack, Vlad, and then I'm going to. That way you can get a really good idea of what's going on and explore it kind of in your own way. I'm going to add file from my computer. It pops up, and this is hopefully the right file. All right, this is that is not the right file, so let's try that again. So it may be that I just need to copy that out. So I'm going to copy my kube, HH, is it HH? Yeah, it's packet. Packet, HH, I'm going to put that in my downloads folder. Downloads, and then I'm going to click again to share my download with my friend Vlad. Click on the downloads folder.
Yeah, I just ping you on Slack so you can see.
I see it. Why is it not showing up? I want to put it on my desktop. I'm not a Mac user. There we go. Today. Now you will have my my box, my key, my cluster, and I'm going to do the same thing that I'm going to expect you to do.
That's your kube config, right?
That is, and that's all you need to pair together in this flow. So I'll export my kube config to be equal to .kube, and then the file that I just sent you, packet HH kubemax. I can do kubectl, get pods, and all the spaces. That's not lovely. Of course, demo day. There's a cluster certificate and my certificate and an endpoint. Let's try this another way. SSH to root at.
Should
I'll go into Packet real quick so we can actually see the box deployed. Normally this comes right up. Inside of Packet, we have an organization for the CNCF, and we have a couple of projects, CNCF Sandbox and whatnot. This is the Packet API Snoop project. And we just brought up, I think it's because I had multiple boxes up there. Which one is newer is kind of the question. Let's say should we root that one? Because if the other one's up, we'll just use the other one. Up, fine. This one's been up 21 minutes. So we may go just use the other one real quick. SSH to root at the other one. Permission denied. We're in, and kubectl get. So there'll be a kubeconfig in roots or in. Let's see, Kubernetes. This is our admin.conf. And so I'm going to copy the Etsy Kubernetes admin.conf into my .kube. Kube config, and then sudo cp sudo chown ii.ii kube, and then I'm going to pop out real quick and scp that over here. So the .kube config to kube config. And I'm going to try this one. Did we not change? Oh, we changed the folder, but we didn't change the file. .kube. Backing out, scp that here. I'm going to send this file to you. Always have a backup in case your demo dies. That's what this demo dies. This one is in the cluster API folder, so I have to go.
Thank you. You have it visible. Just copy it back to demos again.
It's, I'll just copy it back onto my desktop real quick. Thank you for your patience today. CP, it's kube config.sh into desktop. I'll go over here and copy on my desktop. Kube config HH. All right, I've sent you this one. Let's make sure that that one works. And export kube config to kube config HH. Kubectl will get pods here. Did the certificate stop? Oh. All right, we'll do one last quick approach to this to make this easier. SSH, can I get your GitHub username, Vlad?
It's first name, last name, no space, lowercase. Via Vladimir, last name Vivian, Vivien. You miss a slash en. VIVIEN. I'll post it in the.
Trying to pull it up on your profile. There we go. It's first name dot last name. Got it.
Oh, no dot.
All right. This one?
You have an extra A. It's just EN. VIVIE. There you go.
This will get you in.
Okay.
So the IP address here is,
It's pretty cool. I didn't realize you could pull keys directly from the.
all right, I'll drop the host to you. So you should SSH to II at that. And so if I back out as well, like I'm gonna SSH to II at that address, and now we're in. And then on the host level, we won't have a lot of things going on, but our kubectl will get pods and stuff should work. It looks like there was some problems with Weave coming up, which means everything's going to be pending. Even my backup one's not working today. I'm sorry, Vlad.
Yeah.
Let me schedule.
Looks like I still got the same issue.
Yeah, we'll circle back around.
Yeah, no problem.
Let's go ahead and look at the rest of the agenda. Back to here. And we need to decide on the conformance meeting to meet this, to go ahead and commit to that. I will put that in the channel. Stephen, do you want to go over your redirect?
If you just open up the link below. And can we, yeah. So the test I was hoping to get some feedback on, if there was actually a way of using the REST client to be able to stop on line 299. I've got a comment there around it's at this stage doing a 500 because it's doing an automatic redirect using, if we scroll up just a fraction, it's using the REST client at this in that part of the test. So I switched to using the this HTTP client to do the redirect, and of course at this stage it works inside the cluster using our current tool chain process that you were just demonstrating, Happy. But doing it from outside the cluster, I've got a little bit of an authentication issue where I'm setting on 322 where I'm setting the authorization bearer. Of course, that's working inside the cluster, but outside it's not. So I was hoping for some feedback on the difference between inside and outside of a cluster for this stuff.
Stephen, do you want to drop in your teammate session or your kubeconfig, and we can take a look at that in lieu of what I was trying to do earlier?
I haven't been, unfortunately my box at the moment is still, I've disconnected from it from yesterday, but I don't, let me just quickly see if I can flick across to my other box here.
Take a look while if you can. If not, don't stress about it.
Yeah.
Vlad, one of the things we're trying to do is there's a bunch of endpoints, the proxy endpoints specifically, that the conformance definition is that they provide a 301 redirect. In order for us to test this, we need to actually see the 301 redirect and verify that it goes to the right location. If we use the Go client from Kubernetes, it consumes those and doesn't allow us to see the 301 redirects. So we're forced to use the HTTP client raw in order to feed the REST APIs that we need and then look at the response string without following it, because we don't need to follow it. We just need to verify that it goes to the right place. When you're inside the cluster, I believe Stephen is pulling up the configuration for the client. He sets it a little earlier here.
The client configuration
client
is a little bit further down.
All right.
On 3.12.
Yeah.
So that's
you're
where I'm creating the initial client, add in the transport configuration, and then I set the new request. It does the actual request down on 3.24.
the problem that you're having, if I remember, Stephen, is that when you connect out to do, you get an error when you're outside the cluster, because the bearer token that gets set, and that's where you set it here, the bearer token is how things are authenticated within the cluster. But
Okay.
when we're running the CI job, or when you're just using a kube config outside the cluster, it's likely there is a different authentication method in place.
Yep.
Because you don't have a client certificate in cluster, you have that, that authorization token that sits within a file in a special location on the disk that the Golang libraries know how to load. I think in the initialization of we need to retrieve from Golang at runtime the correct way to connect to the cluster, both with the IP and port, which seems to be working, but also because where do you choose the IP and port?
305. I actually do.
So you do pull from
host.
client config host, which is correct, but we're going to need to pull from client config not only the host, but the client certificate or whatever authentication mechanism that is automatically picked up by the Go client library.
Cool.
I don't know that this is accurate. I am wildly speculating here. Vlad, if you have any thoughts.
I think I've come across the reference for the CA file and stuff. So yeah. I will do some more exploration later in the day.
Yeah, but it looks like on 309 you're turning off TLS check anyway.
So Stephen, I think we did that so that because we don't load the TLS certificate to verify the server. We should probably. We need to pull that server verification somehow, but I think that'll be a little bit difficult. And since this is a test and we know the endpoints are set correctly, that's less important. However, I don't think the API server is going to authenticate us unless we have an HTTPS client certificate, which is how most kube configs are laid out.
Yeah.
Okay. It was just based off the kubectl, the raw logs was actually showing the kill command using a K option for just skipping the verifying this certificate. So that was the hint that I was using there.
I wonder if they actually do that in the code, or if they're putting that out there so that the curl command is shorter and fits in the logs and isn't overly verbose.
I'll look at doing some more checks and seeing what the differences are. But yeah, I think I've got enough extra details to move forward on my own now.
My hope is that f.client config has both your client private certificate and your public key for the SSL server verification that you can work into your HTTP client request. But I'm not sure.
Yeah, I think it should have everything you need to talk to at least the API server.
Yeah. Thanks.
Thanks, Stephen. That's excellent work. Thanks, Vlad, for your feedback on that.
No problem.
It sounds like our use case of bringing up the cloudy bits may be over what you need. We are almost at our time for the meeting, I think, if I'm looking at the clock. But I want to offer to you, Vlad, if you want to schedule a pairing time, I will just work with you to bring that that kind-based, local kind cluster-based deployment of it up and running, so that it works for you. Because I would love to have your feedback and participation in that flow.
Okay, I think I told you that I will take you that on that offer. I just haven't had time because I'm very curious about how conformance, how the whole thing, how the mechanics of it work.
You know, one thing we missed that would help a lot with that, I thought it was on the agenda, but I may have just accidentally skipped over it. Oh, there it is. It's right there. It was the next agenda item that we nearly missed. Here's a proud job and a Kate's YAML. So if you want to see this, if we look at this proud job, we're trying to go ahead and have a release blocking job. And this is just the outputs from that job on the CNCF's proud instance that actually runs the database. And we'll just skip to the important part at the bottom. There are 0 untested endpoints that got added. And on this other one, the failed one, you tried to add 101 new endpoints. That's not allowed. and that would be a CI signal for the release not to go forward until those endpoints had tests. If you want to run that job yourself, here is a Kubernetes job YAML that you can just kubectl apply. So I'll drop that into the chat. And we may have to, we'll do this again when we have a larger audience. I probably should have shifted the demo to the end, and I misordered that.
Kubectl that does work to connect to my.
Everybody else is working, mine's broke. I did something. I'll claim the fail on my part. If you run, and we can do that real quick, it doesn't take terribly long. So if I copy that URL and we go into a kubectl, because I should have a working class here, kubectl get pods. Not this one, so I'm gonna unset kubeconfig, so we're not using the broken one, and this is my local kind cluster. And if I do a kubectl apply -f, right, it does URLs. Apparently not.
But it's not the raw file, though. It's the. Does it bring?
What is it?
Does it need to be the raw file, or is it okay that it's the snoop blob?
I'm unsure. This is the.
That will probably be the rendered one. You need.
Oh wow, we got to get the raw.
You got to get
that was
one.
that was HTML. That's not going to work. you gotta do this one, which obviously looks a lot nicer. And I'll drop that in. Like, that's definitely the file. But what you want to do is kubectl apply -y or -f, right? Kubectl apply -f for file. And if you do that, then you get a kubectl get jobs. There's our job. And if I get the job, snoop gate. There's our job, and I think it's logs. Is that how that works? It's still container creating, so we have to wait for it to get there. So if I describe the job, it's probably pulling down. Now it's created the pods, so it's still container creating. I wonder what it's doing.
It's a fairly decent size.
Yeah, it's a pretty decent size image. It's been, you know, when this job comes up, it's the same job you saw there. the upstream image is inside of our API Snoop repository itself. So, or GitHub org, so github.com API Snoop, and there's a SnoopDB repo. The same repo that URL came from. And it is a pretty cool, this also uses a lot of org files for how we create it and build it. You can connect back to the database itself without a cluster, because the work that it does, this is the Postgres. All of our database functions here, that run from our org file, in the end, create a load all audit events that, what is that initial function? It'd probably be at the end. Do you know the file type? I'm looking for mainly the Python functions, because I think that would be of interest.
The Python functions are outside of here. They're loaded into the container itself.
You're right. It's Snoopy
There it is.
build. Yeah. So we'll have.
The other one that you're wanting to look at is the function load audit events.
Got it.
And that's in the initdb with the SQL file. It's number 6.
Number 6.
Because we're actually doing quite a lot of it now that is just SQL directly.
Yep. Vlad, I would start, if you want to understand how the underlying deep things work, this file here is the function, the SQL function we load when the database gets created or when the container comes up. And it does use some Python code outside. This is where we from Snoop utils determine bucket job and download and process audit logs. And we'll look back at those real quick. It just goes through and determines what's the most recent successful jobs in test grid. And it also downloads all of the stuff so that we can pull it back in the DB. I won't go super deep into that. By default, we pull our logs from the Jenkins, the old Jenkins logs Google storage bucket. And we have a releases URL from the Snoop DB that also says where was 120, 119, and whatnot defined. We can probably bring that up as well. We should probably do this in another call, but this may be helpful for you as if you want to see where things are going. Where's that other file? So here's the Python file that I'm dropping in. Each of the buckets, when they get created, has a finished.json. And that lets us know some information about the job so we know what version it was. And then we go through and inject the audit logs in there after we've downloaded them into the DB, into a really nice schema that allows us to query. And they're anywhere from 1.5 to 3 gigs. Zach, did you see any over 3.5 gigs?
No.
Yeah. They're big. It used to take us, oh my gosh, we had some Golang code written to try to parse and shove the raw, and it was Golang code to parse the JSON and shove it in the DB. And Zach's got it down to 4, it's under 5 minutes.
Yeah, it's around 2 minutes.
2 minutes. Excellent. Yeah. And that underlying database is in that image that was built, but you can also see it driving API snoop.cncf.io. Zach can speak to it, but I think this is a static front end as far as the code that's loaded and then the JavaScript. But then the JavaScript reaches out to grab a JSON file that we generate using this SnoopDB to say what are the endpoints and how are they hit for the various releases. So when you hit switch releases, you can go back to 115 and see what that was like. And this is all of the endpoints. We also have a set of endpoints that are ineligible. So if you click on conformance one over here, this list of ineligible endpoints, there's 60. And we have very specific reasons why these are not part of the goal. And here's the remaining debt. So if you want to, like without using the database, you can click here. This is the 196 endpoints that need tests written for.
So they don't have, so the tool was able to figure out that these do not have conformance associated with them.
That's right.
Okay. That's a lot.
I'll show you one of the query.
Open your kubeconfig. Oh, did you send me one?
Yeah.
Just a second. I have a working kubeconfig from Berno, and I'll download his to my downloads folder. And do you mind if I upload it to him? Okay, and I'm also going to go over to Slack and send it to the lab, so you can actually see what it looks like when you're not on my computer. This is one of those chances where it does not work for me. That downloads or put it? Yeah, packet BB7. I think if I had renamed mine, it might have worked. So, and I'm going to go into our shared area and export kubeconfig equals downloads, and it was called packet BB7. So kubectl get pods here. It looks a lot healthier than mine because everything came up. API Snoop, the first thing you see there is the audit logger, and that is a simple bridge between the API server sync and the Postgres database.
If you give them that export, you can do this locally.
Do what?
If you give them the export command.
Oh yeah, so let me know when you're connected, Vlad.
Oh, I'm sorry. I didn't realize. Do I have that one? Do I have the new one?
It'll be Slack.
Sorry.
It's okay.
I see it.
It's dev day. You get to do
You get to be-
dev exploration.
This is what it looks like inside the cluster. Blue pill, red pill. I don't know which pill it was, but there was a pill.
Okay, so.
And once you have that, we're going to do kubectl exec ti dash. We got the dash namespace bb7 qmax dash attach. I'm going to run that to see if it works. It does not work. Kubectl exec. Pod or type name. Oh, you have to say the pod. Is it just bb7 humax? Yeah, that's the one. No.
What's the zero?
Oh, you're right. I did miss the 0. So I'll make sure it works, and then I'll detach, and then I'll paste this. So once you got that kubeconfig working, the way you pair is you run this command. Well, not with all the escapes thing, just that.
Send in the export as well.
Yeah, and you have to export the config. Mine looks like that in the shared screen, and I'll also send that to.
Oh, okay. I was trying to.
Just the two things. If you have kubeconfig and kubectl, that's all you need, and a terminal. And I'd suggest iTerm too, if you have it.
Yeah, that's what I have.
Yeah, beautiful. And I will go ahead and run the command I've given to you, and we will actually see you join at some point.
Yeah, let me set the, because I was trying to pass it as,
Like, yeah.
A flag.
yeah, as a flag, and it's not liking it. So I'll just think about this. I'm using fish.
Then I want just to. I love fish, but fish trips me up with random things. I'm like, why are you?
Yeah, that's one of them. I'm like, I have to think about how to do a simple, well, there's no export. So keep config is.
I don't know if it'll go well on the recording, but if you want to share your screen, I've enabled multiple people sharing their screen. And you just go to the terminal window. You don't have to share your whole screen. I think it's.
Right.
understanding what's going on between the two of us so we can kind of see how the pair session works would be a great recording for later. I also want to respect Glad. It's meeting time over, but it's just I and you right now. So
Okay.
I
won't be able to stay too long because it's 6 p.m. on my side of town.
That is fair.
But I was just gonna try to. What's this file? Anyway.
Next time we'll come with the kubectl first, rather than the walkthrough. Well, you should walk through it from within the working one and watch. Let's deploy one from deploying one rather than.
Okay. Is it yours or mine? No, that's mine. Echo.
Export my own fish.
So you just exported it, right?
I just set kubectl, and I'm sure you could set the command line parameter would work just fine. It doesn't matter, just as long as that kubectl command, that kubectl exec, is using kubectl.
Export my own fish here.
Yeah, let me see. Unable to connect. I'm still. Still getting the X509.
Is the kubectl var pointing to that file and it look right? Like if you do kubectl view config, like I'll do that outside of mine. It's kubectl config view, and it'll redact the things. But does the current context bb7 humax admin at bb7 humax? Because I've sent several files, and it's the last one that I sent.
Let me see.
Because the other ones, yeah, they were broken. I'm not sure. It's because networking didn't come up on my Kubernetes cluster.
They are old stuff. I don't think it ever worked.
Do you have the bb7 file that I sent?
That was the first one? Oh, the last one, right?
Last
yes.
one, yeah.
Oh, crap. You know what?
Yeah. And well, so many configs, so many clouds, so many clusters.
We might have to sprinkle some barriers into this.
No, what happened was, there you go. I was doing some, I was pressing tab and was auto-completing the old one.
Right.
Said something.
Here's our flow, just a quick one to go through to identifying features. And this is running in cluster. So this does a SQL and it updates the content down here. So if we were to delete this area and change
so how'd you get this screen?
That's the end result of it. So what you're seeing is tmate running within a pod that has Humax running on it, that has the API Snoop repo checked out, and we're in the tickets folder, and we're opening the file in order to go through and write tests, or change the branch and check the thing out somewhere else. And this is connecting to, and I'll just go over here. Now that you're in cluster, kubectl get pods is still communicating via that socket. It's an admin token, so we can do all the things to the cluster that we could without. But now we're both typing together. This command here was just limited by 15 to identify a test. If we wanted to focus on something, we would just put the kind and possibly the operation ID inside here.
So the file that you will end up exporting for the ticket is what you are launched into for the cluster.
Like, let's say we want to work on anything with pod. There's lots of pod stuff. What's something you're interested in?
No, pods is fine.
Okay, pod.
Yeah.
And then we know we're going to work on pods, and then we go find the deck. We won't update it, but the URLs inside here are pointing to the documentation for the Kubernetes API and the client Go of a mock test. I think the original test line says, create a pod with a static label, patch the pod with the new thing, get the pod, insert the thing you're interested in. It's just a general output. You could totally replace it with whatever you're doing. And then we have this Go line code. And we're not going to write something. We're just going to comma, comma. And that actually spawns out and takes that code, sticks it in a temp folder, runs the Go compilation thing on it, and captures the output so that it's stuck in there at the bottom of the file so that we can verify it. And because we're running an audit logger, we can actually capture the API interactions of this Golang block.
Now, folks contributing upstream to Go interested in creating their own compliance tests, do they use the tool like this, or do they?
No.
Is it driven directly from GitHub? Do they have to come down?
I don't. So we have the audit logger there, and the audit logger can be deployed independent of Humax. So you don't have to use our Emacs or Humax Flow or anything.
Okay.
You could just use the audit logger, and that is in a different repo. So, but I mean, it's actually in the same repo for API Snow. If you back up and look, we have, I believe it's a customized, right? And we have a customized, and I think the focus for that is actually our apps. Yeah, if we go look at the customized, I'm trying to remember all the things. There will be a customization file, and it pulls from these YAML folders. And you really only need, for right now, the Hasura, Postgres, and Audit Logger, because we don't use the web app or pgadmin or tilt when you're doing deployment. So if I wanted to go look at the, backing up to the apps folder, to look at Audit Logger itself, there is an index file. That's how we do our org files, and it's all the documentation and the source code all in one file, and it gets tangled out to the various pieces of code. In this case, the app is just a JavaScript file with its container and package JSON. And this one turns the, it listens on the right port, and the API server sends the logs here, and it turns around and injects them into the database, specifically into the bucket API Snoop and the job live. And if we go back over, so without using our tools, you could just query the database to see what your applications are using.
Yeah, I think that's what I was asking is like the 196 untested area. Let's say I wanted to create a test for one of those, for one of those endpoints.
Yeah.
What's the starting point? Is it what we're looking at on the screen, or is it somewhere else to start contributing?
So there's two parts. One is identifying an endpoint of importance to you, and having the audit logger, the audit sync running to where you can identify them. Oh, we're using that, and that's super, because look at the user agent on that. That's a super important piece of software for us that allows you to prioritize that endpoint.
Okay.
And that's not necessarily part of the flow. You could just note, looking at your own logs, that's an important thing that's not tested, because the list is there. It's 196.
Right.
Pick your poison. And then you need to write a test. And we happen to also run audit logger while we're writing our test, so that as we're writing it through, are we hitting it or not?
Right.
So that we can create a ticket that says, for sure and for certain, this ticket absolutely hits the endpoints that are not yet tested that are of interest to us. And we prioritize it, in this case, just based on what we're finding. There is no prioritization. It's basically when we find endpoints that are not conformant, we throw those into these are not part of conformance. And we have probably a couple of those, probably between 5 and 10 max a release.
Oh, okay. Because one thing but we'd like to start getting into is to encourage folks to write conformance tests. So I think part of it is, if this tool can help, or is it just a tool that lets you see what's not written, or is it something that you can use as a starting point to start the process? But it sounds like you're saying you don't even need this tool. If you know what the endpoint is, you go ahead and create your
You're
test and you're
writing
good.
for it, right? And then what's sad is that we used to have the dynamic audit sync. So if anybody had the dynamic like alpha enabled, basically, then they could just kubectl apply and deploy not only the audit sync, but configure the API server via the dynamic audit sync to point to that deployment at runtime. Because we lost that, it was deprecated as an alpha feature in 1.19. You have to modify the startup parameters to API server, the binary, inside of API server container, normally deployed by kubadmin, to have the audit definition and the IP address and port of the audit sync.
Okay.
And so that requirement all of a sudden makes it a little bit hard for most vendors, I would suspect, to easily bring up API Snoop in cluster. And we thought about looking at other dynamic APIs like an admission controller or something to where we can get those API calls. But in order for it to work, really, we need to have the user agent, the HTTP user agent, to identify not only which pieces of software, but we updated the E2E testing Ginkgo framework for Kubernetes to include the current test that it's on, the full long string. And we use that user agent full long string in the audit logs to verify that a particular endpoint is hit by a particular test. And we filter on conformance to go, was this endpoint hit by a conformance test or not? Okay. I don't, in order for it to be useful in general, we need to basically, we have a Helm chart for API Snoop. We can use that Helm chart to deploy API Snoop in this way, but you have to point your API server at it to begin with. So it wouldn't necessarily need to run in the cluster that you're testing. It's just an audit sync. So you could run it as a service nearly, or bring
Yeah,
one
that's
up
what I'm trying to understand is, you know, what the starting point is. Okay.
If it's just VMware wanting to contribute and write tests, then I think you can identify the endpoints that are important to you without going too far.
Okay.
If we're wanting to write a service or a tool, if you think about how, what is the tool from now VMware? Oh, you are VMware.
Sonoboy,
right?
Yeah,
Sonoboy.
that's it. I'm the lead for Sonoboy, so I'm trying to figure out.
There we go. This was supposed to work like Sonoboy, right?
Yeah, I'm trying to figure out where Sonoboy could be useful upstream, and I've been tasked to kind of look around and in conformance to see if there's anything we can do and help in any kind of way.
My initial thoughts before we lost dynamic audit sync was that we had something just like Sonoboy, but for conformance.
Right.
And when you ran the kubectl apply from the dynamic GUID at the Sonoboy site, I don't remember the URL, but you have this, what's the name of the site? I forget.
Sonoboy is just something you download and it deploys on the cluster.
There was either a web-based product or something where you went to the site at Tanzu or at the.
Are you thinking Heptio?
Heptio, yes. Was it Heptio?
Yeah, I don't know if we have an actual website. Maybe, I don't know. You could be right.
I haven't seen this. You need to see this. So give me a second to find it. So Sonoboy, and I think it's in the README on top. It's pretty. There was a prerequisite building and latest release, getting started, results page, detailed data. There was a website that ran and you clicked on, I want to do it, and you clicked on new, and it gave you a, like this is still command line stuff. It wasn't like that.
Yeah, this is all command, unless they changed it like way before me joining.
This might have been before you, and we figured that out, but there was a, and it was called something. Like, is there a Sonobuoy domain or website? Because there used to be. Oh, there, sonobuoy.io.
Yeah, that's the site you were just on.
And then there was, it is not here anymore. Because there was, now the getting started is all command line. So
Yeah, it's all command line.
What you did is you went to this website on Sonobuoy and you clicked on new, and it gave you a GUID, and it said, for to get started, go kubectl apply -f this GUID/sonobuoy.yaml. And it deployed Sonobuoy onto the cluster. And when the cluster was done, it uploaded the results back to Sonobuoy. And they had a web page that showed them the results of their tests, which is brilliant.
That's interesting.
That's not go away. I think that should be hosted by the CNCF. I don't think it should be hosted by.
Right.
So if you want
that's
just
interesting.
that part, that's the good stuff there. And if we can find a way to do it and bring back the ability to do a dynamic audit sync, you could deploy the audit sync inside their cluster and dynamically say, send out API calls here during the run of the Sonobuoy plus API Snoop, and give a profile. Like you say, leave this up and running and run all your important stuff. And then upload it, and we'll show you just this Venn diagram of stuff that's not tested and the stuff you were using that's important.
Right.
Something in that Venn diagram in the middle.
That is very interesting. I mean, right now, Sonobuoy does the E2E/conformance tests.
Yeah.
That lives inside Kubernetes, and that's about it. And then at the end, it gives you a result document, or I think it's a JSON that lists out tests that were executed and passed, et cetera, et cetera. That's the extent of conformance right now within Sonobuoy.
Yeah. Those tests get uploaded here, and the pull requests are, we wrote the bot that tests those to make sure that they're verified and ran all the tests that are required. That's a slightly separate use case from run something similar to Sonobuoy on your cluster and run all your super secret stuff that you probably may not want everybody to know about.
Right.
But summarize the Venn diagram of, here are the user agents, and you could maybe even, if you needed to, just go ahead and upload the user agents, because they probably know it's not a super secret what your user agents are. But you're getting to choose which user agents you want to do in the report, because you don't want everything. You just want the things that you wrote.
Right.
Maybe we could limit it to a namespace and then say, these are the pieces of software using things. Because it's almost like for Debian and a couple other, they have the popularity contest package. And it looks and see your installed package and say, these are the popular things. In this case, we're kind of trying to create a popularity contest for APIs that do not yet have conformance, so that maybe someone else can help write the test too.
Yeah, I mean, I'm definitely willing to, continue this conversation to see what Sonobuoy could be useful upstream. Nothing necessarily specific to VMware, but definitely something useful for the rest of the community.
What would be super useful, Lad, that you probably have access to that would be helpful is the people and the source for that that dynamic kubectl apply for that Sonobuoy style thing, because it was a YAML deployment of Sonobuoy, which we could use just that framework, even if it's not Sonobuoy, or use it as a base to change the way that Sonobuoy does its reporting for a CNCF tool for conformance, so that we could possibly even move away from submissions on the repo or speed things up. So you just run the tool and fill in the who you are.
Yeah. So right now, Sonobuoy, it still works the same way, where you could tell it, you generate the YAML and then you say Sonobuoy apply or kubectl apply. So Sonobuoy will generate a YAML for you with everything it needs to deploy itself on the cluster and run all the tests, et cetera, et cetera. Once you have that YAML, you can apply it, wherever your cluster is. So that still is the case. But I'm very interested to continue this conversation so I can understand the use cases you're mentioning.
I'm glad, because I think that's going to be very useful. And I think my ask for within the VMware is to go find the website that I don't see anymore. That didn't run Sonobuoy for you. It generated the YAML under that GUID that had a status page.
I will ask around. I have never heard of that.
That is some good stuff. And I actually tried to base our work on that approach so that we could easily onboard other people to show them, because we were at the first of this project way back like 3 or 4 years ago. We were trying to figure out how to have, right now we're worried about conformance for clusters, but what about conformance for applications? Because then you could go through and run this and check your user agents and make sure your user agents don't hit anything outside of GA.
Right.
The GA as application guaranteed to run on VMware and Apple and Google and all the other cloudy bits. But it only works well if it's super easy to deploy, just like Sonobuoy in the early days didn't need really anything other than kubectl. I go to the web, click on generate me a YAML URL, and then that deployment included uploading it back to that website.
I will ask her. I've never heard, but then again, I'm only a month into this. Yeah. As far as taking over Sonobuoy, but all I could say is right now, it's a couple things Sonobuoy is doing. So one is you can still generate the YAML, but it's all CLI. And the other thing that was added earlier this year is the ability for Sonobuoy to create plugins for Sonobuoy. So if Sonobuoy core doesn't do something, doesn't meet some kind of requirements, you could create your own plugin for it to do. And basically the plugin is nothing more than a pod that gets deployed onto Kubernetes. Yeah. So yeah, I think there's definitely some synergy to get something done here. I definitely want to continue this conversation to figure out how we can, how Sonobuoy could be useful and, what you're doing. But I'll ask around because I've never heard of Sonobuoy having a GUI, and maybe
my log, see if I can't find it, because it was definitely what piqued my interest around Sonobuoy getting really broad adoption in its approach for getting people to share the results of that together. Because it's one thing to run it and get the results locally, but then we've got this go upload to GitHub process, and you can't really have this. Well, what do you do with your cluster? What APIs do you hit? Or even all of this, or even suggestions to say, based on your usage, here are your RBAC rules. Based on your usage, here's your, you could totally have an advice as a service based on dynamically creating an audit sync. And it can run in cluster. They don't have to upload all their logs. You could just, sorry about that.
Huh. That is very interesting.
I want to value your time. I know that it's after 6, and
yeah,
you should walk away from the machine.
All right, guys. But that was definitely. I'm excited to continue this conversation to figure out what we could do and what I can do to make Sonobuoy helpful to the process. Definitely.
Excellent. Have a good evening, and we'll see you on the Slacks.
Okay. Bye.
Good evening. Cheers.